Hi everyone, welcome to Differential Calculus. Today we explore lesson 2.1, the tangent and velocity problems. This section introduced us to the concept of limit, very useful in this class and beyond. Number one, the tangent problem. Definition, the word tangent means touching. Question for you guys. There's a line tangent to the curve fx equal 1, 0.1 x squared at x equal 3. We call this line the tangent line. And it has the same direction and slope as the curve at x equal 3. What is the slope of this tangent line? Let's sketch out the tangent line at x equal 3. We have an x and we have a fx, x3 is f of 3. From algebra, we cannot find the slope of the straight line using only one point. Fortunately for us, there's another way that we can figure out the slope of the tangent line. We just have to use another point on the curve. Let's just pick an arbitrary point. X and fx. We can sketch a straight line through these 2 points. And this line is, call it the second line. Second line has slope, change in y over change in x. Change in y is fx minus f3. Change in x, x minus 3. Notice that if we move the point on the right side of the second line to the left side, the slope of the second line becomes the slope of the tangent line. Let's do a demo here. Okay, let's take a look. As we move this point B toward point A, you see that, oh, slope of the second line becomes slope of the tangent line. Pretty cool, huh? Okay. Slope of tangent line is the limit of the slope of second line as x approaches 3. Slope of tangent line is usually considered as the slope is equal to the limit of the slope of second line as x approaches 3. We use the notation lim for limit x go to 3. Slope of the second line fx minus f3 over x minus 3. And ta-da! This is where limit comes from. 2. The velocity problem. 4 centuries ago, Galileo discovered that the distance fallen by any freely falling body st is proportional to the square of the time t it has been falling. We can represent this by a function. st equal to 4.9 square at the time t is t square. The number 4.9 comes from gravity. Once we get to the later chapter, you will be able to come up with this number, 4.9. Here's the question for you. If an object falls from a tall building, what is the instantaneous velocity? That is the velocity at the exact moment of the object at a specific time. Let's say 5 seconds. Well, we have no idea because we don't have anything to give us this instantaneous velocity. What we know is we can compute the average velocity. So let's begin from there. Average velocity is change in position over change in time. Well, this is the same as distance over time. We can take the average velocity between 5 and 6 seconds. Distance is going to be S6 minus S5 over 6 minus 5. So that will be 4.9 6 square minus 4.9 5 square over 1. And this would give us 53.9. In order to figure out the instantaneous velocity, we need to take the difference between 5 seconds and the time after 5 seconds in a shorter and shorter interval, because we want the exact velocity at 5 seconds. And the best way to do this is use the table. Time interval. This size average velocity 5 and 6. Then the average velocity is 53.9. 5 and 5.1. Do the calculation and you get a 49.49. 5 and short the time interval 5.01. 49.245. 5 and 5.001. 49.0. 49. 5 and 5.0001. Get 49.0049. It looks like that the average velocity on a shorter time interval is approaching 49. So we can see that the instantaneous velocity is the limiting value of the average velocity, which is 49. The instantaneous velocity is the limiting value of the average velocity, over, shoulder, and shoulder, palm, interval. So far, we have learned that limit comes from the tangent problem and the velocity problem. Thank you for watching. See you in the next video.